Okay, hello. Today you're going to do some personal work about reflection, refraction, and some other topics, but you should have three things in front of you. First, as you can see, the PDF that I gave you last time about reflection and refraction. Another one that is the one that you'll need to print, cut, and stick it in your notebook based on what I will explain on one notebook from a student from last year. Much easier, otherwise by computer is very difficult to make it better than this. So first, let's start with this PDF. So you'll have it in the email, print it. If not, draw everything that you can see. It's not that difficult to draw, but if you can print it, it's going to look much better. So what do you need to do? It's about light waves. So for the past few days, we talked about reflection, refraction, and what are they if you still didn't understand? First, what is a light wave? It's about light, no? When you look at light all around you, light is traveling from the sun to your eyes. And how? By using waves, by using vibration that we call photon or quantum of photon. Now that light travels extremely fast. Now she made a mistake here. It's 300,000 kilometers per second. 300,000 kilometers per second. So here she made a mistake. And it doesn't need to have matter. So space is empty, can travel through it, there's no problem. And that's a huge difference between light and sound. Why? Because sound needs at least air. It needs a little bit of matter to produce that vibration, where light doesn't need it. So light, as you know, can be subdivided into different waves that you call color. The red, orange, yellow, blue, indigo in this case, and some more, okay? But understand that when you separate sound, you can produce sound that are more high or low. Here, light can be subdivided into different vibrations that we call color. Now, depending on the material that you use, light can behave one way or another. So, if a material is if a material is transparent, it means that light will go through it. Very simple, like a window. Translucent means that light will bounce a little bit on it or go through it, depending what molecule it has in front. An example of something translucent would be a bottle, these kind of a green bottle from a wine bottle, I would say. So when you look at a wine bottle, is that greenish effect, that darkish effect. And what's going on? Some light will go through it. That's why you can see through the wine bottle, but it's not perfect because some light waves bounce on it. When it's opaque, it means that it doesn't go through it. So it's the opposite of transparency, opaque. Something that is opaque would be a wall or the ground or something that is not transparent, okay? Now, depending on the material, the light will have a special effect. So when you can see on the translucent one or the opaque one, light will bounce on it. When light bounces on something, it's called reflection. If it's a perfect reflection, it means that it's going to be perfectly symmetrical. So when you look at the reflection of a mountain on a lake, it's a perfect reflection. It's all symmetrical, okay? But a reflection is simply when light bounces on something. When light refracts, okay, it's when light goes through matter. As you can see here in translucent or in transparent, light goes through it. But because the material is made of molecules, the light will go through it, but it's going to be hard. Like imagine you going through a forest. You cannot go straight because otherwise you're going to just hit a tree. And if you hit a tree, you're going to change direction. Same there. When refraction goes through matter, it will go through it, but because it will bounce on some molecules of that material, it will change direction. This is what we call refraction. No, and you know it because when light goes through something that is made up of, let's see here, the last one, the beautiful photography from the Life magazine. As you can see, the woman seems completely deformed. And why? Because light doesn't travel the same way through air than through water. And when it reaches the camera, everything looks deformed. Why? Because light changes direction compared to the light that comes from the air, from our head. Okay? So refraction will produce some deformation, where reflection should produce some symmetrical images. Absorption. Absorption is extremely easy to understand. Absorption means that the material will absorb, will suck some of the light wave. And to understand that, let's see if we have something here. Oh, the orange. No? The orange is orange. Why is it orange? The leaf is green. Why is it green? Very simple. It's because of absorption. So, in this case, the material is red. Why is it red? Because all the light goes or touches the material, everything is absorbed except the red wave. I told you here at the top, light is made of different waves, of different colors, 7 different colors. So depending of what is absorbed or what is reflected, the material will have a special color. Again, on the orange absorbs all the light waves except the orange waves. So you see it orange. The green leaves is green because it absorbs all the light waves except the green that reflects. So this is the theory of the day. Then the second part, let's correct what you've done last time. Some student complains through Clickadoo saying, oh, we still didn't understand. It's very visual, okay? So you have 3 choices. This is about reflection, refraction, absorption. Let's look at it. Here we have a perfect symmetry. Why do we have a perfect symmetry? Where did I talk about symmetry? When I talked about reflection. So the first one is a reflection. Here, the woman looks completely deformed. Why did I talk about deformation? When I talked about diffraction. So this is a diffraction. Here, light, the laser here goes through a different matter. Here it's air, here it's a type of like plastic or wax or glass, and it changes direction. Where did I talk about changing direction? Refraction. Here same, we have a change of direction, and the head of the man is completely upside down. It's refraction, because the light had to go through that glass and change everything, all the direction change, and we have a deformed image. Same here, the car is nice and big, the car is nice and small. What is it? Refraction. Here we have, and that's more creative, we have a beautiful photography of the reflection of a woman, of a different woman, into the mirror. So we have reflection. The image of the girl that is somewhere on the left reflect onto the mirror, into the camera. Here the laser bounce. So when you see something bouncing, it's about reflection. Here it's the orange, we talked about absorption. Here we can see that the light bounce. It's about reflection. Here it's a beautiful picture of the Life magazine again. The girl is in a magical square of light. Where does it come from? It must be a reflection from the sun onto a window, onto the ground. So it's reflection, it's bouncing somewhere else. The sun is orange. Why? Why is it orange at sunset? Ooh, when we talk about color, that's about absorption. Due to the atmosphere, all the light goes through all the molecules and changing direction, so we may have a little deformation of the sun. But why is it orange? Because we have an absorption. On the light wave that only come to your eyes is the orange color, due to the amount of molecules that we have in between. Absorption. That was a little tricky one. Here, be careful. It's about Photoshop. There must be a guy in the shoes there, but we got rid of it. But it's still a reflection of the person into the rainy floor that you have. So, what do you need to do today? Let's repeat. Correction of what you've done last time, printing this PDF, and doing this on a new page in your notebook. This is your job for today.